All right, so we're doing substitution method here. I would probably say that this is less likely for me to do a substitution method, but I am going to show you why you could do it in substitution method because the goal in substitution method is to make sure that you have a variable by itself. And if it's already by itself, it makes it a lot easier to substitute it into the other equation. Because x and y in the first equation are 1, it does make it a little bit more of a better setup, but I'm going to show you, I wouldn't necessarily use this, but I'll show you how you can do substitution method in this. So I'm going to decide to get the x by itself because it's a little bit easier to do. So I'm going to move the y over to the other side, and I'm going to have x equaling y plus 2. Now, what that allows me to do is take this, and the x is equal to this part right here. I'm going to take it and replace it in the second equation where it is. So it's right here next to the 4. So I'm going to say 4, and then in parentheses, I'm going to replace the x with the y plus 2. So that's going to be placed in here. And then I'm going to go ahead and complete the rest of this equation. So minus 3y, and that's equal to 11. Now I'm going to do the distributive property. 4 times y, and then 4 times 2. So 4 times y is 4y. 4 times 2 is 8. And then we have that minus 3y equals 11. Now I'm going to combine like terms. 4 minus 3 is 1y. We have 8 equal to 11. And we're going to subtract 8 on both sides, getting me y equaling 3. So I've got the setup, I've got y by itself now. I know y is equal to 3. Now I'm going to go up to my original equation. I'm going to start with the first one. So I'm going to replace it in the first one and check that one first. I'm going to solve for x now. So we're going to do x minus the y value, which we just said was 3. And it's equal to 2. So I want to get x by itself this time. So I'm going to add 3 to both sides. And then I get x is equal to 5. And so now I have my x and y coordinates. We know that they work for the first equation because 5 minus 3 does give me 2. And when I plug it into the second equation, if I plug in 5 here, I've got 4 times 5, which is 20. I plug in the 3. 3 times 3 is 9. And 20 minus 9 does indeed give me 11. So I know that both of the equations are true when I plug the equation numbers back in for substituting. And so my answer for this would be 5, 3, because we write these in coordinate form. So this would be your finalized answer, 5, 3. And again, if you are worried that TikTok is going away, you can always find me in my YouTube channel, You Want Algebra, same name, different platform, but all the videos are all the same in both areas. And if you want more questions like this, you can find these in the equations section for systems of equations and a new category, substitution method.